So welcome to the Lightning Talks. We're going to go through 6 topics in the next hour and 15 minutes. I'm going to start us, I looked at some of the other topics and they go pretty deep, so I'm going to start us off nice and soft and just kind of give you a little story about my experience going to a Fullstack bootcamp in Tokyo. And what I learned from doing that and how to appreciate developers outside of just being a database developer. A little bit about me real quick. My name is Mike Donnelly. I've worked with SQL Server for about 15 years, and I did live in Tokyo for 4 years. So, right into it. Living in Tokyo, I sort of did a hodgepodge of remote work for US clients, and I did have some significant amount of downtime, had a lot of fun in Tokyo. I had the opportunity to go to a 3-month, fully immersive Fullstack boot camp and learn to do coding on a stack, mostly JavaScript, and we were the 4th cohort, and these are the gentlemen that I did that with, and it was a lot of fun. I'm here to tell you that, but there was a very steep learning curve for me. I had never really done anything outside of the SQL Server realm before. Part of my impetus in doing this was, to sort of find out about all those things that I had always heard about, like things like Kafka and Redis and React and Node.js and what have you. But for me, there was quite a bit of learning. And not just learning the technology, which was pretty intensive, but things like pair programming and things like learning how to just build something and not worry about how it gets done because you've got a 2-day deadline and things like that, which and every morning we would come in and do a code challenge, and they got progressively harder and harder to the point where I would just throw my hands up in frustration. We weren't really meant to be able to do them, but it was sort of a test of like, how much can you figure out how to code in how short of a time? But with that said, what I really want to talk about is the stack that we did have a database. This is what we had was it was all JavaScript. Node.js, Express, React. If those don't mean anything to you, that's fine. They didn't mean anything to me before I started the code camp. Primarily, we used Postgres on the back end, which was close enough to SQL Server that I could fake it. But we built a few projects over the course of it, mostly on this stack. We played with some other technologies along the way too. But what I learned was that for the developers and my fellow people in the cohort, the database didn't matter, which is to say, of course, that the database very much matters. But in that environment, and this is where I kind of got it. We were learning so many things so quickly, and over a 90-day course, 2 days was spent on the database. So the amount of emphasis was put on that, and that wasn't just relational databases, that was NoSQL databases and what have you. But it was enough to get us up and running and be able to build projects. And we used all of these different technologies as our back-end database, just JSON files on a file server, Kafka, which is sort of a streaming database, Redis in-memory cache database, MongoDB, which is a way to store JSON in a NoSQL database. We looked at some other things like Cassandra and CouchDB, but I never actually built anything with them. But from the developer perspective, it was all about the API. Sure, we were learning full stack, so we had to stand up a database and we had to have somewhere to put our data. And but for the front end people, we'd usually split up that way when we'd break up into teams to build things. They'd be like, okay, here's the API. I don't care where you're storing it, where you have it. Just bring it back to me. And obviously, these are the kinds of things that don't scale to like a full enterprise, but when you're building things this fast and you just want to see what you can do and get done, it was for me just sort of this click like, oh, no wonder they don't care about the database. They're getting what they need right now and it's working. What really brought it home was we split up into 2 teams, and one team decided, and it was just sort of like a simple web app that tracked like vehicles across the world or something. And we were given the data set we were given originally was in a JSON file, and one team said, oh, perfect, done. We don't need a database. We'll just use everything from this one JSON file that we've given. Of course, the other team had me on it, and I'm like, oh, I'll take this JSON file and I'll create some tables and we'll throw it in Postgres real quick. Well, we finished and they didn't. Because when... Oh, okay, I'm back. All right. when it got down to it, later, right away, sure, they could dump that data into their app and they were good, but in order to add some more functionality into it, they had to have a lot of work going into trying to parse out what exactly they wanted, whereas we were like, oh, just write a query, bring it back to the API, and we have it done. But seeing them, and I'll be honest, our team talked about that too, like, oh, maybe we don't need a database, we can just get up and running, everything's in the JSON file that we need. We're not gonna be storing any data, why would we ever need to put this in a database? It was kind of an aha moment, because I almost agreed with them. Here's my other sort of database takeaway from this. I have spent most of my career cringing at ORMs and query builders and things that build SQL that don't build it nicely. But I gained a new appreciation for them. One of the projects that we had was on MongoDB, and the Mongoose ORM for Mongo basically meant that I didn't have to learn anything about how to interact with MongoDB directly, which is, I imagine, how developers feel that don't have any knowledge of a relational database, and they see an ORM, and they're like, great, I can get my data back and I don't have to worry about it. And for proof of concepts and small projects, it worked great. I could throw data in the database, I could bring data back into the model that I had already built. So it did give me sort of that view into it, like, okay, I get it. I don't think it'll scale well, but I get it. And the other query builder, JavaScript query builder that we used was this connects.js, and I'll confess that was actually kind of fun because it was turning all this stuff that I was learning about JavaScript, and I could see how it was going to build the query because I knew enough about SQL. And one project we had to use this query builder for, so I was sort of forced to learn it, and that was kind of fun. I'll confess. And I did promise in the abstract for this that I'd throw up a bunch of resources. This didn't get uploaded. I'm going to email it and make sure it does get uploaded for this so that you have this list of things. These are all the technologies. And I'm talking today primarily about the database stuff, but if anybody wants to talk to me about building web applications using JavaScript, I'm more than welcome to do that. It was about 9 months ago now, so most of the JavaScript stuff has gone out of my brain, but I can dredge up the projects in GitHub that I have, and and I'll remember most of it. So with that, I know we've got a bunch of other people that are going to talk today, and now I know why I don't call them lightning talks, because I'm talking lightning fast. Thank you very much for listening.
That's really not bad. You got done in record time.
Yeah.
Now I'm like, wait, I got to talk now? All right, so we're on here. Yay. All right. Hi. I guess I should start my own timer, huh? I'm Jen McCown of Minion. You may have seen our big yellow booth at the expo hall, which is now closed. I absolutely lost my place because I got a message. I'm not going to look at my phone anymore. Hi, I'm Jen. You can find me online at midnightdba.com. You'll see all kinds of stuff. But today we're going to be talking about setting up SQL Server Administration and backups in 5 minutes. And that's whether you have 1 server, 5 servers, or 50, or a bunch. It takes the same amount of time. It takes the same amount of your time, as you'll see. All right, so let's go over the quick basics. Why do backups and maintenance, if you've never heard of these things before? Backups of your databases make a copy of your data and the structures that are in them so that in case your server catches fire or somebody wanders in and starts deleting views, yes, that's a thing that happens if you're not really tight on security and or you've got vice presidents that think they should have access to the production servers, so that you will have a backup somewhere so that you can get those things back. Log backups copy off records of all of the actions that happened to the database, all the updates and inserts, and the point of having those backed up is so you can restore and run through those to a point in time, like say, for example, right before they deleted those views. So yes, backups, I find it's very, very important to have native SQL Server backups as opposed to relying on like VM snapshots or on third-party proprietary formats. I don't like that at all. Do you want to talk about why do it? Let's talk about it when I'm not on a 10-minute timer. Checkdb operations look for database corruption. Database corruption is simply when the bits get mixed up on disk and it becomes unreadable. you can see how that would be kind of a bad thing for data. And like you, I'm talking really, really fast, but this is how I normally talk in my sessions, and people are like, slow down, and now I'm like, yes, I'm in my milieu. So Checkdb operations look for that corruption, and you want to, this is so incredibly important. A lot of people, if they pay any attention at all to their Checkdbs, will run the Checkdbs, and that's it. While that's better than nothing, all of that information goes to the SQL log, not the database log, but to the operational log, and you never see it. So you might be cheerfully checking and finding lots of corruption and never hear about it. So we're going to talk about alerting too. Index maintenance, defragments, indexes. If that statement made no sense, very tautological, let's talk about it for just a second. So an index on a table is very much like an index in a book, right? If you want to find information in your book, you flip to the index and you get to that entry. That's a lot quicker than scanning the entire book looking for every piece of that information. Same exact thing with indexes on tables. Now, you can imagine how confusing and how much slower it would be if someone took your book and started ripping out the index pages and putting them in different orders and tearing them in half and putting those in different orders, maybe upside down. That's the same exact thing, except for the upside down part, with table indexes, okay? So we reorder those back into their proper order periodically via index maintenance, very important for performance. So let's do this. I, of course, am going to point you toward my company's free product, and again, 100,000% free, will always be free. It's all native SQL code, all that jazz. So go to minionware.net, and you can go to any of the product pages, backup, Checkdb, or reindex, and you'll see this little Minion Maintenance download. Download it, and you extract it onto one of your servers. So thing number one, we want to tell the system where we want to back up to. We're going to be doing backup, Checkdb, and reindex. The default is on a C drive, and while yes, all computers have a C drive, I don't think you want your production backups going to the C drive. It's a bad idea. All right, let's take a look at that. So we're going to modify the backup location by going to the extraction folder, which is right over here. Is that it? No, that's not it. This is it. There we go. This is where I've extracted it to. I go to the includes folder, and here I see backup include. Now, if you're not familiar with PowerShell, don't be afraid. We'll be okay. This is what it looks like, and it's very, very similar, at least in the variables, to SQL. So here we have backup drive, and here we have backup path. I would probably, at a company, be backing up to a NAS. So I would be like, oh, okay, my NAS, my share is a company name, and I want it to go to SQL backups. Now, we've got these funny little things here. I am not going to go into that, but it's within this system. Those are little tokens that will replace. In this case, SOSL will replace with the name of the server, and the DB name percent will replace with the name of the database. I personally don't care to have my backups divided up into different folders per database, so I'm going to take that out. I'm also, by the way, going to go back to C because I'm on a laptop and nothing else is going to work. The thing to remember is both of these have to end in a backslash. That's the only thing. Okay, so I've saved that. We have now configured up where our backups are going to go. Huzzah. What comes next? I don't know. I have to get back to my notes. There we go. I said before how important it was to alert on Checkdb. So we're going to do this as part of this. We're about to get to the installation, but I want the Checkdb alert and the job that runs that to be part of my installation. Any server that has the Minion Checkdb running on it, I want this alert on it. I'm going to download that from the community zone. Out on Minion, where we have a community zone. Ta-da! And right here at the top right now, because I just updated it, is the Checkdb corruption alert. We download that, we save it, and where we save it to is our Checkdb folder. Now before, again, that's the wrong folder. There we go. Before we were in includes. Now we're going to go over to Checkdb, and lo and behold, look at that. I've already saved that off. This is what I have downloaded from the community zone. It's just a stored procedure and a job already scheduled. So sticking a script in here is great and dandy, but we have to actually tell the installer, oh, by the way, I'll run this too. And the way we do that is we use this install order and make sure that that script name is right down there at the bottom. So when I run the installer, it'll go through and it'll go, oh, okay, I'm going to do the tables file, then the indexes, and very, very last, I'm going to do this too. This is a very, very powerful feature, by the way. I'm going to warn you to be a little careful with it. That's all I'm going to say about that. All right, so we've got all that, which is fine, but we need to edit that file. Is this it? Is this it? This is, yep, this is the Checkdb alert. And what we want to do is tell it where the alert should be sent, right? We don't want it to be sent to, let's see, what's the default? Alert email recipients, because that is not a real email. So we're going to do a, come on, give me a replace all. There we go. Turn off regular expressions. Then I'm going to say, I want it to go to me, jen@midnightdba.com. Yes, that's my real email. Yes, you can email me. Cool. So you only have to set this up once, okay? That backup configuration, this email, we never have to do this again. It's already done for this folder and everything. So anytime we install from here from now on, we're good to go. Now here's the great thing. We've got this lovely installer script right there with you. It comes with Minion Maintenance. On my box, it is in that Minionware folder. It is setup master, and it takes parameters. The parameters it takes are server name, DB name, and maintenance type. Well, we can put in a pipe delimited list of as many servers as we want. This is why I say it takes 10 minutes to get this stuff set up. Where are we at? I've got to look at my timer. We're at 8 minutes, 11 seconds. I'm going to say, okay, for all of those, I'm going to install Minion Maintenance in master, because I know that exists out there. And I want to install all 3 maintenance modules, backup, Checkdb, reindex. For my box, I don't have access to anything else, so I just have to say localhost. Let's clear that out. There we go. And now I go Minion setup master, localhost master, all done. We can go home now. Our backups are Checkdb, everything's set up. It's scheduled, it'll run, we'll have logs, there are retention periods set, everything. Bye, see you later. Just for the fun of it, we're going to play around a little bit more. Anything else we do from here is a bonus. Also, anything else we do from here, we can incorporate into that installation. And by the way, you can rerun installation. It's not going to like delete existing settings unless you tell it to. Be careful with your installer. So let's say we want to change just one server or 1 or 2 server schedules. All right, so I'm going to go out and look at my Checkdb settings server table real quick. All of the scheduling that we do is table-based. I don't want to have to do multiple jobs for different schedules for different databases. You can't see it very well. Let's see if I've got Zoom it running. Of course it's not running. Why would it be running? Pardon me a moment while I open Zoom it. But what you can't see right now, because it's not quite running yet, is that we run system Checkdbs every day at between 10 and 10:30 p.m., and we run user Checkdbs Saturday between 11 and 11:30 p.m. And let's see if Zoom is working now. Hey, there we go. I don't like that. I'm going to update that and set a new schedule just for my Saturday Checkdbs. Oh, yeah, I need to actually select that again. There we go. And so now what this says is, oh, okay, on Saturday, I want my Checkdb operations to start anytime between 11 a.m. and 1 p.m. Any time is good. The reason we do it that way, by the way, I better hurry up. There are reasons why we do it that way. But that's you're updating your schedule. The last thing I'm going to do is say, all right, we want to, I promised in the abstract that we would go in and change backup tuning thresholds. If you didn't know, you can tune backups. We've got a session on that on midnightdba.com, Sean's famous backup tuning class. For now, all I'm going to say is it's very easy with Minion Backup to say, oh, okay, I've got a set of backup tunings, and that involves, so for any given database over 20 gigabytes, I want to back that up to 4 files and use these other settings that are going to make my database backups run faster, and so forth. So it's incorporated. We could just as easily run this script and then say, oh, okay, we've got that all configured now so that as any database grows and gets to, let's say a database grows to 50 gigabytes, then it gets the next set of settings. That is my time. Ran it just slightly over. Thank you all so much for staring intently at me while I got through this. And for more information, minionware.net or ping me at Hey Minionware.
Thank you. Welcome, and thank you for attending this session. My name is Dennis Torres. I'll talk about hidden secrets of Varchar Max and text data types. I'm a Brazilian living in Malta, working for iSend Software, a software house in Malta. So I'll be delivering this session in some kind of Malta English. So if you don't understand some word, please feel free to stop me, ask me to go slowly and anything. This is our agenda today. Let's see about replacing these types and many demos. Why should we replace the types? Why should we replace text by Varchar max? Text fields are deprecated. This means that they will not evolve and they could be removed on any SQL Server version. This is already a very good reason to avoid text fields. Varchar max fields are the replacement recommended by Microsoft. Microsoft recommends that you use Varchar max. Text doesn't support equality. Text doesn't support goodbye. And since text is deprecated, it will not evolve. The new features will not be able to support text. No developer of new SQL Server feature will be concerned about supporting text. So what will happen is that future limitations will continue to appear, more and more and more limitations. So besides all this that I just told, let's talk about data storage and page size. SQL Server stores the data in page inside the data file. So help me on this. What's the size of a page? 8K, 8 kilobytes. So that's the size of a page. These types that we are talking about, they are also called large objects. What's the maximum size of a large object? I mean, a text or a Varchar max field? 2 GB. Exactly. The pages are 8K and the field is 2 gigabytes. So what would mean that we are putting an elephant inside a car? That would be difficult. It's impossible to put an elephant inside a car. Maybe we could put the elephant over the car, although I would not recommend that. But the best solution may be link the elephant to the car, maybe use some chains to attach the elephant to the car. So in this case, you already know where I'm going with this. Everyone thinks, everyone believes the large objects are not stored together our data. The large objects store a pointer together our data, and they are really stored in another place. Everyone usually believes that. But the point is this true? Let's see now if this is true or not. So, I'm using Azure Data Studio. I have here one table with a text field, and I'm inserting 200 records inside this table. At the same time, in another database, I have a table with a Varchar max field, and I'm inserting the same 200 records inside the table. So, now that the table has the records, let's check the page allocation of this table. I can check the page allocation using sysdmdb database page allocations. It's difficult to make a straight line here. So let's check the page allocation for the table with the text field. What we have here? we have two kinds of allocation unities. We have in-row data and lob data. In the in-row data, we have a single data page. In the lob data, we have 54 what are called text mix pages. So this proves that using the text field, it really puts a pointer for the data, and the data is stored in another place, in another allocation unit, the lob data in this case. But now let's see the same thing in relation to the Varchar max. Let's see the page allocation of the table with the Varchar max field. And surprise, there is no lob data allocation unity. We have only in-row data allocation unity. And we have 38 data pages for our data. Okay, it's different, but what's the consequence? The consequence of that is, what if I need, not good with the zoom here. Let me improve the zoom now, yes. What if I need to make a query that doesn't retrieve the big field, the lob field? I need to retrieve only the other fields, not the lob field. Let's see how this query behaves with the text field. So here I will have the result of the query, and I use statistics.io, and I have a total of 3 logical reads, nothing more, only 3 logical reads. Now let's see the same query with the table using Varchar max field. The same query will reach 40 logical reads. 40. This means that the conclusion of this is that only by changing from the text data type to the Varchar max data type, you are losing performance. You are deprecating your performance. That's true. That's true. How do we solve this? What's the solution for this problem? Here I have a third table using a Varchar max field. And here is the secret to solve the problem. All tables which use Varchar max fields needs to have the large value types out of row enabled. This table option needs to be enabled to solve this problem. So IO execute is the same script, is creating the table and inserting 200 records, but this time activating this option before the insert. And the result of the page allocation is that now we have quite the same result than we had with the text field. So it's not only a matter of change one data type to another and believe they are the same. They are not. So you need this table option. Let's get back to the previous connection. And I have a query here. I'm querying over some system tables to check which tables have a Varchar field and if this option is enabled or not. Here I have an existing table which has a Varchar max, not only Varchar max, and this option is not enabled. So what I do, I enable the option. Let's just enable the option for the table, that's it. Okay, the option is enabled. Let's check the page allocation again. No solution. It's exactly as it was before. What's the problem? The problem is that when we enable this for an existing table, the data will not move. What will happen is that according the updates and the inserts, the data will be inserted in the correct place, especially the updates, because the updates will move the information for the correct place. So it will happen according to time. But what if you need a better read performance now? How do you solve that? Let's try an extreme solution, very extreme solution, just to exclude other options. I will drop the primary key constraint, and as a consequence, I'm also dropping, in this case, the clustered index, and I'm creating it again. So I dropped the primary key and created again with a clustered index. Let's execute the page allocation again. Let's check the page allocation again, and nothing changed. This means that an index rebuild will not solve your problem. Then the solution is really an update. The solution is scary. It's an update with software. It's very scary, but it's the consequence. Now we check the allocation, and we have 54 log data. Great! The data were moved for the correct place, but we still have 38 data pages. What happened? Well, the data were moved, but the pages are still there, maybe empty. So we complete this sequence, just running a reorganize on the index, and now we check the allocation again, and it's complete. The change is complete on an existing table. I'm sorry, I think I passed a bit the time. There are differences between text and Varchar max. This difference affects performance, and the important point is that there is a table option that needs to be configured to solve the problem. Thank you very much.
Okay, we have only 10 minutes, and let's do this fast. Okay, okay, number 1, number 2. Okay, silence your phones, blah, blah, blah. And you export everything. Okay, this is me. I am a SQL Server DBA. I have been working for Carnival for some time already. And this is my email. And my mission in life is to work the least amount that I can do of work. So, yeah, good, thanks. And for this, I use PowerShell a lot, and I use Python. I used to switch between the two. Depending on the conference I am, I will promote one or the other. I'm here, this is PowerShell. But really, PowerShell rocks big time. I'm sold. Okay, continue. Okay, this is what we are going to be checking. First, I'm going to show the book definition of what a workflow is, and we are going to make a little hello world workflow program, and we are going to make a sample program using jobs. Jobs was what used to be used before the workflows. And now I'm going to do later a sample program using workflows. And next, we are going to have time to do the jobs program converted to workflow. And at the end, we'll have a goodie. Okay? The goodie is really good. How many people here are complete newbies in workflows? This is for you. Okay, continue. Okay, this is the book definition. Windows PowerShell workflows are designed for scenarios where these attributes are required: long-running activities, repeatable activities, frequently executed activities, running activities in parallel across one or more machines. We are going to concentrate on this only in this 10-minute thing. And interruptible activities that can be stopped and restarted, which includes surviving a reboot of the system against the workflow is executed. Okay, not that one. And now we are already tired. We need a little break and a warning. Look at this. This is a video from Jeff Snover, the creation of PowerShell. And it is highly recommended. When you go to the 5 minutes, you watch the video and you see what he says. He says, PowerShell is like programming with hand grenades. Wow. When I saw that, that was an incredible motivation. And it's really true. If you have done anything in PowerShell, you know that with one line, you do incredible things. In that, PowerShell is number 1. Okay, yes, that is true. It is like programming with hand grenades. But I have to add this. After working with PowerShell workflows, I have to add this part. Yes, working with workflows is like walking on a minefield. And this presentation, I hope it will serve as a mine detector. Okay, continue. Boom. Okay, this is the sample, the workflow program, the hello world. No, not this. Okay. And in the beginning, we define the workflow, and we can put like some stuff in the beginning, and after that, we have the magic, the parallel keyword, and the brackets. Inside the parallel, you can put anything, and they will run all in parallel. And after your parallel stuff completes, you can add another section and do a closing activity. And how do you execute it? Just execute run workflow. In this example, very simple, what I do is 3 delays, 60, 35, and 25 seconds. If this works, the total time should be 60 seconds. Yes, it works. You can see it there, believe me. So now you know that workflows work, we continue. Okay, this is a jobs programs. Jobs, you use them and they work, and you can run things in parallel using jobs. And jobs in 10 seconds is what you see in the top right of the screen, where you do the start job, get job, wait job, and you receive it. And in this case, what I have is a list, a file with several servers, database names, database folders where I want the files, and the name of the action I want to do. So my program takes first the list of servers, makes a loop out of it, and for each one of them, depending on the action in the text file, I do either restore databases or I do restore logs. You could add a lot of a gazillion actions in this program, like I have them at work. Okay, now, fast, go, go, go. Okay, now, this is the meat of the thing. What you see here is a prototype that you can use to do workflows tomorrow. You just define the workflow. First of all, you get parameters passed into the workflow. And now you see the second part of the magic. This is still better than the other parallel. This is for each parallel, and you pass items, you are going to be doing the same thing we saw before. And you can do this, and after you complete the parallel action, you can do some other stuff at the end. How do you run it? Same thing. You run the workflow, and you pass the parameters. In this example, it's computer 1, 2, 3, 4. Okay? So, good. We continue. Next. Now, this is a sample program that I did that is very, it can be used in your local computer because it has many features packed in a little place. This program, what it does is this. First, delete our output files. Later, we are going to generate text files that are extracted from a database and saved as CSVs. After that, we are going to compress the files. And at the end of the process, we are going to send an email report of what happened. So you can see this using the same structure. We go here, and we get the parameters, and we compress, and we extract the files, and we do everything, okay? There are a lot of, I have all this source code in my links. Okay, and now we continue. And if you have done a workflow, you are going to see the familiar colors. You get the screen, and you see the files produced. And they are compressed. You can see the blue color. And you see the email report. Okay? Continue. And now, in the beginning, when you are doing workflows, you can do this. You can do a lot of outputs things. Later, you'll notice that this may interfere with performance. So yes, use outputs, save outputs, but later remember that you will have to code on that. Yeah, chatty output helps the newbie. Okay, and this is the other program that I mentioned before using jobs. This is the same thing converted to workflows. In this case, we define the workflow in the top, and we get the parameters. We use the same structure, and this, I have more things here, but this is cleaner. The workflow is cleaner than the jobs. And we do the same thing. We were either restoring databases or we were doing restore logs depending on the input file. Okay, in this case, there is a little difference. Before we start the workflow, we get our list. We do a query to get our list of actions. No, we don't do a query. We get the content from the file, and we run the workflow passing the list obtained from the file. And that's it. And now we continue. I had time to do it. It's amazing. Okay, so now we get the goodie. Newbies, you have to look at this very, very attentively. Look at this. This is the goodie. You add value to your resume with these simple steps. Find one of your favorite PowerShell scripts that you use. Add this in the beginning. Workflow, the name of the workflow, inline script, and later go to the end and put the reverse brackets. And type and run the workflow. 99% of the time, it will work. And you know what? You are doing workflows. That is amazing. And now what you do is this. You edit your resume, and you put, I use PowerShell Workflows, if you are a modest guy like me. Or if you are a really guy who is a young guy and wants to get that job, you do this, proficient in the use of PowerShell Workflows. Okay? Well, amigos, this is everything. All the source code is here. You can see it when you get the presentation. And this is the link to Snowbird talk. And this link that I put at the end is the most compact thing I've seen for workflows. And now we do this. Hey. Thank you, everybody, for your patience. Okay.
Okay, so we're going to talk about memory-optimized table variables. Who here knew you can put table variables in memory? That's a great point. Well, nothing has happened yet, so let's find that cable and put this on the screen. You could have waited a while. That would have been funny. Oops. Let's go back to the first slide. Nah. Let's see, does it come up? Flash, yes, go. Awesome. I'll continue right where I left off. That was perfect. Great. So I'm Ed Pollack. I'm a senior DBA over at Datto in Albany, New York. I love doing data stuff. I love speaking. I love writing. I've done a lot of things, but we're not here to talk about that today. So we'll skip right past the me slide. If you care, you can find me later sometime, but we don't have time for that. We want to talk about in-memory table variables. Who here has heard of them and knew you can put those in memory? Not a lot of hands. Great. If you did, that's awesome. If not, we're going to talk about them because they're cool. What's our agenda here? We're going to review temporary objects and how they work. We are going to talk about what these things are that I'm talking about, why I'm even here, what's the point of this 10-minute thing, why do we put these in memory, why does it matter, a speedy demo, because demo isn't a fly or fun, who knows what will break, and then we're done. That's a great agenda for 10 minutes, right? So, temp tables and table variables. How do those work? The classic ones, ones we've always used throughout history, back since the beginning of time. How do they work? First off, they're stored in TempDB, which means they live on your storage system, not in memory. If you thought they lived in memory, you've been tricked. Table variables and temp tables live in TempDB. They are stored in there. They are subject to all the things that databases do with your data, like storing them in files and everything. So they're not in memory, and they have to read. There's latching and locking, and all those good things can happen just like data in a database. You can index them. That's kind of cool. Indexing table variables and temp tables will make them faster. You can target them with most stuff that you would target a regular table with, also useful. And because they're in TempDB, they're subject to the latency of your storage system. So if it's an SSD system, it's as fast as your SSDs. If it's a SAN, it's as fast as your SAN. If it is something off in the cloud, it's as fast as the something in the cloud is rated to be. So wherever it is, that's as fast as it is. And when your session ends, you drop them, they go poof, and they're gone forever, which is what we want. You don't want to put them as actual tables in your database because then they're permanent and they get backed up and they're part of your schema and all that. You want temporary. Temporary is great for things you want to go away forever. And global temp tables, don't use those. They're insecure. Anybody can access them. If you use them, think about replacing them. They're a bad idea. We're not here for that. So how do they work in memory? Well, they're actually stored in memory, first of all, and not in TempDB. So you're getting all the speed of memory in your system, which is generally faster than your storage subsystem. You can also index them, clustered, non-clustered indexes, hashes, whatever you want. It's like memory optimized tables. Who here has used memory optimized tables in memory OLTP? Okay, cool, some people. Less hands than the people that talked about in-memory table variables. That's confusing. Again, you can target them with most of the DML and DDL that you can possibly think of. In newer versions of SQL Server, in 2014 it was more limited, but we've gotten past that, and that's good. So your limits here are not your storage subsystem. Your limits here are server memory. So if a temporary object's going to be a terabyte in size, well, you should probably rethink your temporary object first of all, but you probably don't want to shove that in RAM unless you have a terabyte of RAM waiting for you. So keep in mind that it's going to use RAM instead of storage, which is probably fine for most temporary objects. And just like before, when the session ends, batch is done, poof, they're gone forever, which is what we want. Temporary objects go poof, and we like that. So what's good about this? Well, no reads, no writes, no I.O. If you do stats I.O., there'll be nothing there because you're reading from memory, and that's wonderful. There's no latching and locking. You're asking, what heck, how can there be no latching and locking? Well, latching and locking occur when you're reading data back and forth from your storage system into pages in memory, and that process is conducive to latching, like, oh, I have to wait for data to get into memory. Hang on a sec. Or I'm reading this here, but I'm waiting for this. Hang on. If it's all in memory, there's no waiting, there's no hanging on. Life is good. So the big boost here is queries that will consistently touch and retouch the same data over and over in a temporary object will benefit greatly. Like if you're inserting, updating, deleting over and over and over a lot of data, this will speed it up a lot. It'll also avoid log growth. Because if you create temporary objects in TempDB and read and write and do stuff, that actually impacts your TempDB log file. And you can actually blow out your log with giant temp table operations. In memory, not a problem the same way. What is this ideal for? ETL, data loads, crunching all kinds of numbers and data and things where you really want to do things over and over and over, shrink it, compress it, play with it, update it, all in temporary objects. This is a good thing. Also could be very useful in places where performance really matters. Like if you have data and you're pulling it into a temp table and you're doing that in like a function or a trigger or a place where you really care about performance, that's a good way to do it. All right, so how do we use them? First, you've got to configure your database for your memory OLTP. I'm going to demo that in a sec. It's a command, you're done. Next, create a table type. So the difference between this and a regular temp table is you have to actually create a table type for it, the structure of it, and define it. Once you've done that, you're done, you move on, life is good. You declare a table variable using that type, and then you go ahead and use it like any other temporary object. The remainder of this is the demo of how does this look. That was interesting. Where did my screen go? That's not good. I have a demo here. Escape? So there's the PowerPoint. I escape it. Close PowerPoint. So,
Stop presenting.
very funny, very funny.
Must have bumped it.
You think so? Oh boy. Window P. These are things that didn't happen before.
Try to duplicate.
All right. There we go. All right, we're good, we're good. All right, let's keep going. Awesome. Great. A little bit of adventure there. All right, let's start this out here. So, quick demo of how this stuff looks. So first off, we got to create a file group for in-memory memory optimized data. This is important. Next, we got to deal with file names and stuff. So I'm going to go ahead and alter the database and add an in-memory file. I'm just doing a little bit of SQL here to identify where my files are stored so I don't have to go hard coding it because no one likes hard coding anything, if possible. There, now we have a file group and files. Now I'm going to create a type, a couple types actually, just for data. Keeping this very simple. It's just the structure of a table in AdventureWorks because it's simple and we can demonstrate it. The only difference between this and a regular table is we have non-clustered hash index here for one of the columns. And then we have memory optimized on. That's really the only difference is memory optimized on, done. So we create our type. There's our type. We create our second type for a different table. Done. Step 1 complete. Step 2. Now, let's demo this with standard tables. I'm going to run a bunch of queries here using standard tables, not stuff in memory. So how's this going to look? We're going to declare a table. These are regular old table variables. They're indexed the same way, but they're not in memory. We go through, we insert data, update data, insert data, do a bunch of stuff. Stuff. We run it, our workload against this structure of 2 tables, and there we go. We get our data back in a couple of sets of data. The data doesn't really matter, the result sets. But I can look here and see, wow, these are kind of intensive. 10,000, 100,000, 30,000, a lot of logical I/O going on here. You're taking the same data and playing with it over and over. And so what just ran pretty quickly here on my speedy laptop really was like hundreds of thousands of reads of pages, which is a lot of data for a pretty small amount of stuff I'm playing with here. So lots of reads. If your storage is slow or your data is bigger, like billions of rows, this will take a while, and you'll wait, and it'll be painful. All right, so here's the alternative. Let's go ahead and put it in memory. So how does this look? First off, we declare our table variable as a type that we created before. So this is the type we defined earlier. This is the in-memory object. We declare them. Once they're declared, it's just like any old table, just like before. All the rest of the syntax here is basically the same, except that I just added some suffix to all these to give them different names. We're going to insert and delete and update and do all the same kind of stuff as before, do some selects. So I go ahead and I run it. And I got an error. That's great. Really? We'll go back and fix it. Really? Maybe. Let's go ahead and... This is version compatibility, isn't it? All right, well, it ran before. So here we go. Here's what actually would happen. And this is actually a very easy thing to talk about to avoid talking, is here's what you would see. If I went to the screen and ran this, and it was all in memory, for stats.io, what would you see? What would you see in that giant list? Before we ran this, stats.io, and got endless list of I/O. In memory, what do you get? Nothing. You would read your data, and as soon as your data is in memory, you would see nothing more. Execution plans wouldn't be very different, but your data is in memory, so you would have no logical I/Os, no reads. And so if reading off your storage subsystem is a drag, this eliminates that. That's the key to this all. And these were never advertised heavily, which is why I find them very interesting. This is just cleanup. So the key here is that this was never advertised much. So what ended up happening was, let's go back down. All right, great. So because it wasn't advertised much, in memory, OLTP was introduced in 2014. It was Hackathon. They kind of rebranded as memory optimized tables. They never really talked about the fact that a temporary object can also be made in memory. That kind of got slipped to the wayside, and no one really ever spoke of it. So as a result, nobody really used them. But they're extremely useful, because now you can replace temporary objects that are otherwise dragging on your storage, put them in memory, and now they're fast. So how do we wrap all this up? Temporary data is perfect to go in memory. Memory is a volatile place. Things don't stay there. Your server crashes, all your temp tables there, it's gone anyway. Who cares? This is the perfect place to put temporary data, not just temporary data, but non-durable temporary data. So the right place for it is in memory. It can make your query performance go from slow to fast, just like that. The only cost you'll incur is reading data into memory first, but once your data is generated and in memory, everything else you do will be very, very quick. You can reduce contention and churn on TempDB. That's key. If you have a lot of things hitting TempDB, TempDB is a database with all the constraints and limitations that databases have. Therefore, let's reduce contention and churn and make it more friendly. This puts it in memory, and you don't touch TempDB anymore. This is a great way to relieve the stress in that database because it is a database, and it behaves like a database. If you target it with too much stuff, it will eventually get slow and cause you trouble. 2014 and after, all have this. So enjoy. I apologize for the demo. It worked about a couple hours ago. It didn't work now. I don't know why. That's life. But you know what's going to happen. Nothing gets displayed. Not a big deal. This is why I love lightning talks. They're so quick, you can breeze past those things and no one notices, right? So anyway, thank you very much.
I'm here to talk about 3 tricks for faster index maintenance on availability groups. Thank you. Okay. My name is Paul Wehland. I have been working with SQL Server for a very long time, supporting customers going all the way back to 16-bit SQL Server. I am ex-Microsoft. I worked in the PSS group and then moved to the product group, helped ship SQL Server 7 and SQL Server 2000. Left Microsoft and joined a daughter firm of Microsoft called Avanade. That's where I am now. So, how many people are using availability groups? Quite a few. For the people that haven't used availability groups, I'm going to give a little overview here. Here is a 3-node availability group. We have Windows, or it could be Linux as well. Node 1, 2, and 3 are Windows. On each of these machines, we have a SQL Server instance. In each of these SQL Server instances, we have user databases and system databases. The user databases that make up an availability group are then byte mirrored on every single node in that availability group, here represented by a green line. This applies only to user databases, not to system databases. So master, model are never in an availability group. They are outside of an availability group. TempDB, also system database, not an availability group. We're going to come back to TempDB because it's an important trick that we're going to use here. SQL Client will connect to the listener. Here we see a machine named myAG. The SQL Client doesn't have to connect to node 1 or node 2 or node 3. We can connect just to the listener. The listener will redirect the SQL Client to the appropriate node, whether it's going to do updates or some kind of read operation. It'll be redirected to the primary replica. Perhaps it doesn't need to do any writes. Then it could just do reads. This is great for reporting. You can move your report workload over to secondaries. So there's 2 different types of availability modes. We have the synchronous and we have the asynchronous. Let's talk about the synchronous and the differences between the availability modes. This has to deal with the D, the durable, in ACID transactions. The D stands for durable, and what that means is that when a transaction is committed, it will survive even in the event of a failure. So here we have a log block that's in a log pool. This is going a little deep, but when the commit transaction log operation comes through and is written to that log block in memory, this absolutely has to be hardened to non-volatile storage. In our case, it'll be a hard disk, maybe an SSD, NVMe. So let's look at this. We've got this log block. It's written to non-volatile storage. At the same time, this log block is then shipped to the secondary replica. There's some queuing mechanism in here that's not represented on this animation. But when the secondary replica gets this and sees that there's a commit transaction, this also has to be hardened to durable storage. The secondary replica now can send an acknowledgement back to the primary that says, I've got this hardened to durable storage, meaning if something fails, memory won't survive, but the durable storage will. Then the primary can send an acknowledgement back to the caller, back to the SQL client, say, transaction is committed, and then SQL Server can start cleaning up locks and so on. So that's quite a few steps to go through to send an acknowledgement back to SQL caller, the SQL client. Let's look, I'm going to reset the picture here. Let's look at an asynchronous. What happens in an asynchronous availability mode? It's the same picture, I've just changed the colors a little bit so that there's no confusion between this and synchronous. Here we've got the same scenario. We've got a commit transaction log operation that needs to be hardened to durable storage. It's written then to durable storage, and the SQL Server will send back the acknowledgement saying, transaction is complete. Secondary, asynchronously then, these are shipped to the secondaries through a queuing mechanism, and those are then hardened to durable storage, and an acknowledgement is then sent back to the primary. So that's the big difference in durability between synchronous and asynchronous. Back in database mirroring, it used to be called high safety and high performance. And I mentioned earlier that the databases are kept in byte level mirrors. They are identical to one another. How does that happen? Through the transaction log. The transaction log is just a temporal recording of every operation that's ever occurred in the database. And by keeping track of all that, all of these secondaries are in the exact byte order and the exact copy of one another through the transaction log. And that brings us to our first trick. Sort your index in TempDB. Why? Because when we sort in TempDB, if we have to do a sort operation that doesn't fit in memory, we have to spill to disk. If we don't have enough memory, we need to put it to disk somehow to sort. Why would we do that in the user database if we're going to have to copy all of these log records and pages and index and sort pages in the database? We can put that in TempDB, sort in there, and then save quite a bit of time. Risk, reward, almost zero risk doing this. There could be some risk. If you're already overloaded with TempDB, this could actually make your indexes rebuild slower. Or if you're already overloaded with TempDB operations, you could slow down your OLTP workload as well with this trick. So you want to test it. But the reward is pretty good. Let's look at this. 50% reduction in time with no compression index rebuild, and page compression about the same. So we can see that in both cases, we also save whether we have compression with sort TempDB off or sort TempDB on. So that's a little bonus trick. That one's not on my slide, but you get that one for free. So trick one, sort TempDB. Sort your indexes in TempDB. Now, trick number two, asynchronous mode. We have another scenario here of risk reward. The risk is we lose automatic failover. In asynchronous mode, we have manual failover. We only get automatic failure in synchronous mode. So there is some risk here, but less risk than if you're not even on an availability group. So recognize the risk. The reward, not as impressive as sort in TempDB, but you'll have to determine if this scenario risk is worth this reward here in your workload. Here are the numbers I got running these tests over and over again. I got between 3 and 10% in this exact scenario here. 7.6 reduction, 6.9% reduction. Could add up if you have very, very long index rebuilds. Okay, trick number 3, bulk log recovery model. Remember I said that the databases are kept in identical order through the transaction log, full recovery model. So when you say bulk recovery model, Paul, how can we do this? Well, we have to tear down the AG to do this. And the reason why this trick works is because when you remove a database from an availability group, the secondaries go back to recovering. And they're still there at the LSNs. They're not dropped, they're not deleted, they're not recovered either. So that's why this trick works. but it's higher risk, much higher risk here. We lose the AG, we lose point-in-time recovery when we're in bulk log recovery model, and it's complex. Let's take a look at how complex this is. We've got in this first box the number of, what we need to do is remove the database from the availability group, then set the database to bulk logged. Step 3, that's where we do the index rebuild. Then we've got the putting it back to recovery, back up the log, then add the database back to the availability group. If we see this diagram here, we see that this foo database is restoring. This is what happens on the secondary after we execute step number 1. When we execute step number 6, put it back into the database, we still don't have it in the availability group. Options 7 and 8 now, we do on the secondaries. This is like manual seeding. So now we can do this by ourselves. It's all manual. Let's look at the benefits here. 71%, wow, that is good. That's even better than TempDB. You've got more risk. But that's just the index rebuild time. And that's not really a fair operation because we're still not in an availability group with this. So we have to, in fairness, to make this a fair fight, we have to add the manual seeding time, the backup of the transaction log, which includes all the minimally logged page operations that occur in your database. So that backup can be quite large. And then the restore of that large transaction log on your secondaries. And if we add that, then we see in my tests a 35% reduction. This is dependent on your hardware too. In some of my tests, my early tests, I wasn't able to get these numbers, and finding out the bottleneck was the backup of the log, and the restore of the log was going to pretty slow storage. When I fix that, this is when I can get those high numbers. I'd also like to play around with the automatic seeding and some of the witchcraft that goes under the covers there, but those APIs aren't really exposed to the public. Okay, thank you very much, and